You ever stop and think about all the stuff that has to happen for your car to move? It's not just about turning the key and pressing the gas pedal. There's a whole symphony of parts working together under the hood, or for a crane to lift a giant hunk of steel. It's not just a simple lift, it's a complex dance of engineering and mechanics. Gears, those are the little guys doing the heavy lifting, literally. They might seem small, but their role is monumental. They're like the hidden muscles in machines, quietly making the world go round. Without them, our modern conveniences would come to a grinding halt. We're talking cars, clocks, airplanes, even your trusty can opener. These gears are everywhere, silently doing their job. No gears, no modern life. Imagine a world where nothing moves smoothly, where every machine is a struggle to operate. Now, most folks see a gear and think, yep, that's a toothed wheel. But it's so much more than that. But there's a whole lot more to it. It's precision engineering, folks. Designing a gear is an art and a science. Every tooth, every groove has to be perfect. A single flaw can throw the whole system out of whack. Otherwise, you get grinding, you get slipping, you get a whole lot of nothing working right. And that can lead to bigger problems down the line. And trust me, I've seen enough busted machines to know that ain't pretty. The cost of a malfunction can be enormous, both in time and money. So next time you're using something powered by gears, take a second to appreciate the ingenuity. Think about the countless hours of design and testing that went into making it work seamlessly. It's a beautiful thing seeing how these simple machines make our lives easier, one rotation at a time. They truly are the unsung heroes of our world, working tirelessly behind the scenes. You'd think gears, being so tough, would be made of some fancy exotic metal, and sometimes they are, depending on the job. But most times it's good old-fashioned steel. Why? Because steel is strong, durable, and can take a beating. Plus, it's pretty easy to work with, relatively speaking. Now, not all steel is created equal. You've got your carbon steel, your alloy steel, each with its own strengths. For gears that need to be extra tough, you might see some stainless steel or even brass. And for those high-tech applications, like in airplanes, you're talking titanium or even ceramics. But no matter the material, one thing's for sure, it's got to be top-notch quality. Any imperfections, any weaknesses, and that gear's going to fail. And when a gear fails, well, let's just say it's not pretty. Before a single spark flies, before a chunk of metal gets touched, you got to have a plan, a detailed, precise plan. That's where the gear designers come in. They are the masterminds behind the scenes. These folks are like the architects of the machine world. They envision and create the blueprints for the gears that make everything run smoothly. They use computer programs and good old-fashioned math to figure out exactly how big, how strong, and how many teeth a gear needs to do its job. It's a blend of art and science. They've got to think about things like speed, torque, the load the gear will be carrying. Every detail matters. Too few teeth and the gear might break under pressure. It could lead to catastrophic failures. Too many and you lose efficiency. The machine won't perform at its best. It's a delicate balance, folks. Precision is key. And don't even get me started on the different types of gears. There's a whole world of them. You've got your spur gears, your helical gears, your bevel gears, each one with its own unique shape and purpose. Each type is designed for specific applications, ensuring the machinery operates efficiently and effectively. It's enough to make your head spin, but these designers, they live for this stuff. They thrive on the challenge. They're the unsung heroes, making sure those gears mesh together just right. Without them, the machinery we rely on every day wouldn't function. Section 4, from chunk of metal to toothed wonder, the making of a gear. This is where raw materials transform into precision engineering marvels. All right, so we got our design, we got our metal, let's make some gears. First up, cutting. This is where the magic begins. Now, this ain't your grandpappy's hacksaw we're talking about. Forget those old school tools. We're talking high-powered lasers, water jets that can cut through steel like butter, and computer-controlled milling machines that are more precise than a brain surgeon. These machines are the epitome of modern engineering. Once the gear blank is cut out, it's time to shape those teeth. This is where the gear starts to take its iconic form. This is where things get really interesting. The process is as fascinating as it is complex. There are a bunch of different methods, but one of the coolest is called hobbing. It's a technique that has revolutionized gear making. Basically, they take a super hardened tool called a hob, which looks kind of like a giant screw, and spin it against the gear blank. This tool is engineered to perfection. The hob carves out those teeth with incredible accuracy. Each tooth is meticulously shaped to ensure perfect meshing with other gears. But the job ain't done yet. There's still more to do to make this gear ready for action. The gear still needs to be finished. This involves several critical steps to ensure durability and performance. That means smoothing out any rough edges, hardening the surface to make it wear resistant, and maybe even adding some lubrication grooves. These steps are essential for the gear's longevity and efficiency. It's a multi-step process, folks, and every step is crucial to making sure that gear can handle the job. From start to finish, each phase is meticulously planned and executed to create a component that can withstand the rigors of its intended application. Section 5, measure twice, spin once, making sure gears don't quit. You wouldn't believe how precise gears need to be. We're talking tolerances smaller than the width of a human hair. That's why quality control is so important in gear manufacturing. Every single gear gets inspected, measured and tested to make sure it meets the exact specifications. They use all sorts of fancy equipment for this. Laser scanners, microscopes, even machines that can simulate the wear and tear a gear will experience in its lifetime. If a gear doesn't meet the standards, it's a no-go. No compromises, folks, not when it comes to something as important as a gear. It's this attention to detail, this commitment to quality that makes all the difference. Because when a gear is made right, it can last for decades, quietly doing its job without complaint. And that's something worth celebrating, even if it is just a humble gear.